Good morning, Algebra 1 students. Hope you're all having a nice snow day and now what has become a 3-day weekend. So as you know, we were supposed to have our Unit 4 test today, and I'm sure you're all getting ready for that last night. Now we don't have it. So what we're going to do is we are going to, of course, move your test to Tuesday morning. But in order for us to make everything work that needs to work with our schedule, what we're going to do here on this through this video is we're going to do the practice today that we were supposed to be doing on Tuesday. Hope that makes sense. We're basically going to flip-flop Friday and Tuesday. So if you've got your packet, we're going to go Unit 5, Day 9. If you don't have your packet, that's fine. You can obviously see on screen here the DMR for today, and I'll make sure that you can see the questions coming up if you happen to not have your packet. So go ahead and pause the video and try the DMR here, and when you're ready, push play and we'll check your answer. Okay, so for number 1, it says use elimination or substitution to solve. I'm going to notice that in this equation that I'm highlighting in purple, the y is already by itself. So since the y is already by itself, I think that this is best set up for substitution. So that's what I'm going to use. So a substitution, I need to take in this case, the purple highlighted equation, and I need to take the 4x minus 7, and then what I can do in the other equation, the one that's not highlighted, I can replace the y with 4x minus 7. So that would look like this: negative 3x minus 5 parentheses 4x minus 7 equals 12. So notice how I have removed the y from that unhighlighted equation, and I've replaced it with 4x minus 7. And remember, the reason why we want to do this is we want to take the number of variables from 2, x and a y, down to just 1. At this point, that purple equation only has x's in it, whereas before it had a y and an x. Okay, so once I've done this, I need to do some simplifying before I try to solve. So that would be the distributive property first. So I get this. When I do the distributive property, now I need to add my like terms. And then finally, what I can do here is do my regular equation solving sort of methods. So I would subtract the 35 from both sides. This would give me negative 23x equals negative 23. And then I would divide both sides by negative 23. This would give me x is equal to negative 23 over negative 23, which is just positive 1. Okay, and then I've got to find the y to go with that. Now, thankfully, this is set up nicely for that. If I just use the purple highlighted equation, I can plug back in with my x. So it would be y equals 4 times 1 minus 7. That, of course, is just 4 minus 7, which is negative 3. So my final answer would be 1 comma negative 3. Okay, hope that went well for you. I think it's pretty clearly shown there with the steps. If you didn't get it, feel free to rewind the video and watch it again. Moving on to number 2. All right, so number 2, you see a little story about a basketball team and their scoring average. And the question says, really the thing we're supposed to do, it says, what was the percent of increase of their scoring average? So we're looking for a percentage describing their scoring increase. So I know that last year they averaged 37.2 points per game, and this year they're averaging 41.7. So my first step is to find out by how many points per game their scoring average went up. I would do this by subtraction. So I would just do 41.7 minus 37.2, and that equals 4.5. Yeah, 4.5. So that's how many points per game their scoring average went up. So now what I'm going to do is I'm going to compare that using a percentage to what their scoring average was last year. So I want to know by how much it went up. So I got to compare it to what it was last year. So I'm going to say part, the part that the scoring went up, so the 4.5, equals the percent, which is my unknown, times last year's score. Okay, so the part that describes how much the scoring average went up is equal to the percent of the whole thing from last year. So what I'm going to do is I'm going to divide both sides by 37.2, and I'll use my calculator here. 4.5 divided by 37.2 is 0.12096. This asked for a percent. In fact, it said round to the nearest tenth of a percent. So this would be 12.096%. And if we round to the nearest tenth of a percent, I would get P is approximately equal to 12.1%. So their scoring average went up by 12.1%. Okay, number 3. Hopefully you read through this one, and hopefully you remember when you have one of these story questions that involve cars or trains, or in this case, ships moving, it's probably best to draw a picture. So it says a cruise ship left Miami and a fishing boat left Miami. So they both left Miami. So I'm just going to say that this starting line is Miami. It says the the cruise ship left Miami at noon and traveled south. So that boat left first. The fishing boat left Miami at 1 p.m., so that one left second, left after. The fishing boat caught the cruise ship at 5 p.m. What was the cruise ship's average speed? So I'm going to represent the cruise ship with a blue line, blue arrow. So I'll call this distance of cruise ship. And then I'll represent the fishing boat with a green arrow. And I made these two arrows the same length because according to our story, the fishing boat catches up to the cruise ship. Presumably because the fishing boat is faster than the cruise ship. Okay, so what I'm going to say here then is, as far as the relationship goes, I'm going to say distance of cruise ship equals distance of fishing boat. They both started in Miami. They both finished out there in the ocean somewhere in the same place because the fishing boat caught up to the cruise ship. So let's remember that distance is rate times time. So I'm going to say rate of cruise ship times time of cruise ship equals rate of fishing boat times time of fishing boat. And I'm going to try to fill in some of the things that I know. For instance, I know that the cruise ship, I know that the fishing boat traveled south at a speed of 10 miles per hour. So that means the rate of the fishing boat is 10. So I'll put 10 right here. And then it says, what is the cruise ship's average speed? Well, that's my unknown. I'll move this over here just a little bit. There we go. So I'm going to say rate of cruise ship is something I don't know. Now the times I don't exactly know either, but I do know that they're related because the cruise ship left at noon and the fishing boat left at 1. So wouldn't it be fair to say that the cruise ship traveled for 1 hour longer than the fishing boat? Okay, so traveled for 1 hour longer than the fishing boat, and caught the fishing boat caught the cruise ship at 5 p.m. So if the cruise ship left at noon and they stopped at 5 p.m., that means the cruise ship traveled for 5 hours. For 5 hours, and the time of the fishing boat then would have to be 4, right? Because they started at 1 p.m. So now I write 5 times RC equals 40. I divide both sides by 5, and I get rate of cruise ship equals 8, and it would be miles per hour. And that has answered the question, what was the cruise ship's average speed? Okay, and then lastly we have number 4. This one says simplify completely, and this is our newest topic, these challenging exponent questions. So here goes. When I look at this first expression, I see that the whole base in there is raised to the 4th power. So my first step would be to write something like this. 3 to the 4th times, it's going to be x to the 20th, because I have a base with an exponent and then another exponent, that 4 on there, so I multiply the exponents, times y to the 8, 2 times 4, of course, being 8. On that other fraction, or the other expression there, I notice that I've got an x in the top and another x in the top. So when I'm multiplying two bases together, I add my exponents. That would give me x to the 0, right? Negative 3 plus 3 is 0. And then I've got a y in the top, and I've got a y down there in the denominator as well. And so remember that whenever you are dividing bases, you subtract your exponents. So 11 minus negative 3 would give me y to the 14th. And the 9 is still down there in the denominator. That hasn't gone anywhere. Okay, now I've got a little more simplifying I can do here. So first of all, 3 to the 4th is 81. And then I notice again that I've got an x and an x. And if I'm multiplying bases, I add my exponents. So that would be 20 plus 0, so I'd get 81x to the 20. And then I also have a couple of y's that could be simplified. Y to the 8, y to the 14, those are being multiplied. Whenever you're multiplying bases, you add your exponents. That would be y to the 22. And I still have that over 9. My final step then would be to recognize that the 81 and the 9 are both bases. And if I'm dividing bases, I'm dividing bases. So 81 divided by 9 is 9. So I get, for final answer here, for final expression, 9x to the 20th times y to the 22. And that there would be my final expression simplified. Okay, so I hope that the DMR has gone well for you. If it didn't, you would be wise to probably rewind and rewatch and retry and so you can get a little bit better at what's going on in here. Okay, so then the practice that I want to do with you guys today is on quadratics. And so there are the first two examples. This is like what we did the other day. This is just basically some practice. So there's numbers 1 and 2. So if you don't have your notes with you, you might want to write these down. And here's numbers 3 and 4. Again, if you don't have your notes packet with you, write them down, because what I'm going to do is have you pause the video, and I want you to try as many of these as you can, and then when you're ready, what I'll do is I'll just go in order, and you can watch my results, and we can compare and hopefully make sure you're in a good place. So pause the video, please try numbers 1, 2, 3, and 4, as many of them as you can, and then check your answers. Okay, so the first question here is, what is a quadratic? So let's review this. We talked about this the other day. A quadratic, the most generic form would be ax squared plus bx plus c, where a, b, and c are all numerical coefficients. So some examples, some specific examples would be things like negative 3x squared plus 7x minus 9. So in this case, the a is negative 3, the b is 7, and the c is negative 9. Another example that's maybe a little bit less obvious at the start would be something like 12x minus 17 plus 5x squared. So this is a quadratic. It's not written in descending order. And so if I wanted to write this in descending order, which would be a good idea, I would write it like this. 5x squared plus 12x minus 17. So I just got to rearrange the order, taking care that the sign in front of the term is part of the term. Now that it's rewritten, I can clearly see that a is 5, b is 12, c is negative 17. And if you remember from before, identifying the a and the b and the c correctly is quite important for doing well with these. Okay, so here's number 1. This is really similar to one that we did last time. So check this out. Identify my a, b, and c first. So a is 1. Getting that from right here. There's no coefficient on the x squared. So whenever that's the case, we know that it's a 1. B is negative 13, and C is 12. Okay, so my first step is to find A times C. So A times C, of course, is 12, right? It's 1 times 12, which is just 12. And this is where I use my little graphic here, where I put the AC up here, and I put the B down here. Okay, so what I'm trying to do here is I'm trying to figure out which numbers multiply to be 12, and at the same time add to be negative 13. And there's a lot of options here. So I could think of maybe like 3 times 4. And 3 times 4, of course, is 12. But 3 times 4 is, 3 plus 4 is not negative 13. So those are out. I could also try 2 times 6. 2 times 6, of course, is 12, but it does not add up to be negative 13. So this might have taken you a while. I have absolutely no idea, but hopefully what you'd find in the end is that if you multiply negative 1 times negative 12, negative times a negative is a positive, right? So that would multiply together to be positive 12. When you add it up, you do get negative 13. So those would be our 2 key numbers. Once I have those 2 key numbers, I am going to make my box. And in my box, I always put the lead term up here in the upper left, so this would be x squared. And I put the C down here, so I've got x squared and 12 in there. And then I'm going to take my 2 numbers that I got with my little x, and I'm going to put those in the 2 diagonals. So it's going to be negative 1x and negative 12x. And again, the ordering there doesn't matter. You could flip-flop those and you'll get the same answer regardless. Once we're done this, we're going to just factor the GCF out along all of our vertical and horizontals. So along that red line, or that red arrow, I guess I should put, there does not appear to be a common factor, so the common factor is 1. But remember that the box we finish with is negative, so I'm going to factor a negative out as well, so this will be negative 1 for that factor. Now factoring along the orange arrow, I do have a common factor. They both have an x, right? So it would be x minus 1 there for the top factor. Now factoring along the blue line, the blue arrow here, the common factor is 12, but again, like before, the box that I finish with is negative, so I'll factor out a negative 12. And then lastly, if I factor along the yellow arrow, the common factor is just an x. So I just collect my 2 factors here, so it would be x minus 1 times x minus 12, and these right here, the green box, those would be our factors of x squared minus 13x plus 12. So remember, these 2 expressions right here are equal. They're the same expression. The one we started with is not factored. The one in the green box that we finished with is factored. We've taken an expression that's not multiplication and we've turned it into multiplication. And of course, if you ever had any doubts about this, you could always just check your answer by multiplying it out, and you should see that you get the exact same expression you started with. Okay, moving on to number 2. Okay, so number 2, let's notice that it is in descending order right now. And so we are going to identify our A, B, and C. So A is 6, B is 19, and C is negative 7. All right, so my first step now is to figure out A times C. So A times C would be 6 times negative 7, which is negative 42. Okay, so you can tell this one's going to get a little tougher just because the numbers are a little bit bigger. But if we stay true to our method here, we should be in good shape. So negative 42 goes up here, 19 goes down there. And we're just going to be figuring out which numbers multiply to be negative 14 or negative 42, and add to be 19. I don't know. The first numbers that jumped into my mind were negative 7 and 6, right? That would multiply to be negative 42, but when I add those up, I get negative 1. So that's not going to work. If I think of, 13 and 4, I could do like positive 13 times negative 4. Well, those multiply to be negative 42, but they definitely do not add up to be positive 19. So hopefully after a little trial and error, you can use your calculator to do this. It might just take a lot of guessing and checking, educated guessing and checking with a calculator perhaps. Hopefully you arrived at the idea that we want to multiply 21 times negative 2 to get to my negative 42, because those two numbers also add to be 19. So like I said, it might take you a little while to get really good at that. It's okay. Just take your time, keep working at it, and you'll get better for sure. Okay, so I'm going to put my box in now. Remember, with my box, I put the lead term here, so 6x squared. I put the last term here. Then I'm going to take my two numbers that I found in my x, and I'm going to put those on the two diagonals. And like I said before, it doesn't matter which one goes where. So I'll just put the 21x here and the negative 2x there. Okay, so now I'm going to factor my GCF on the verticals and horizontals. So I'm going to factor here. Common factor here is 7. And notice that my finishing box is positive, so I'll just factor out a positive. Along the orange arrow, I've got a common factor, and the common factor here is going to be a little bit more than we had before. There's definitely an x in common, but there's also a 2 in common, right? There's a 2 goes into both 6 and 2. Okay, now I'm going to factor along this purple arrow. The common factor here, there does not appear to be a common factor, so the common factor is 1. And since I finished on a negative box, I'm factoring out a negative as well. Lastly, on the red arrow, I've got a common factor of x, but then between the 6 and the 21, there's actually also a common factor of 3. So my final factoring here would be 2x plus 7 times 3x minus 1. So again, like I said before, the expression here in this dark blue box, that is the factored version of my original expression. So those two expressions are the exact same value. They're the exact same expression. It just, the first one is not factored and the one in the purple box is factored. Our goal was to get to the factors. Okay, number 3. Hopefully you're just seeing that this is just practice here. We covered all this on Wednesday, and we're just practicing, just trying to get better. So here we go. First step is to identify your A, B, and C. So A is 2, B is negative 11, C is 12. Once I've done that, I want to identify A times C. So A times C would be 2 times 12, which is 24. Next, I want to identify those two diagonal numbers in my box, and so I usually just use this little graphic organizer to help with that. So I put my AC up here, and I put my B down here. And I'm just trying to figure out which numbers multiply to be 24 and add to be negative 11. So again, should be a lot of trial and error involved here. Might take you a little while, and that's okay. Just keep at it. You can use your calculator if you need to. So you might have started off with, 4 times 6. And that would make a lot of sense because 4 times 6 is 24. However, 4 times 6 does not add up to be negative 11. So we would say it's not those two. Maybe next you try 3 times 8. Well, 3 times 8 is 24. 3 plus 8 is positive 11. It's supposed to be negative 11, though, so 3 and 8 won't work, but maybe this will give us a big hint. If I tried negative 3 times negative 8, That still gives me positive 24 because a negative times a negative is a positive. But when I add negative 3 plus negative 8, that's where I get negative 11. So those are my two numbers. Finally, I'm going to turn to my, my box. Okay, so in my box, I always put my first term in the upper left, so that'd be 2x squared. I put my final term, my c term, here. And then like before, I'm going to take my two numbers that I got from my x, and I'm going to drop them in the diagonals. Negative 3x and negative 8x. The order doesn't matter. I'm just going to put them there because that's just where I decided to put them. If you put them in a different, in the other way, it'll work out fine. Okay, so along the red arrow, I have a common factor of 3, but my finishing box is negative, so I need to factor out a negative as well. So negative 3 is that factor. Along the orange arrow, I've got some common factors here. For instance, they both have an x, but don't they both also have a 2? Right? 2 goes into both 2 and 8. So let's say 2x is my greatest common factor there. Along the green arrow, I've got a common factor of 4 because 4 goes into both 8 and 12. But my finishing box is negative, so I've got to factor out a negative 4. And then finally, along the blue arrow, it appears that I have a common factor of x, and I think that that's it. So my factors for 2x squared minus 11x plus 12 would be 2x minus 3 times x minus 4. And this would be my final expression factored. Again, just a reminder, these two expressions are the same exact expression. It's just that we have taken that original expression and we have put it back into factored form. You could check this by multiplying it out and checking to see that you get the exact same thing you started with. Okay, lastly, number 4. First step, identify the A, B, and C. So A is 5, B is 2, C is negative 7. Once I've identified those, I need to multiply A times C. So A times C would be 5 times negative 7, which is negative 35. Once I've done that, I'm going to figure out my two diagonal numbers. I'm going to put the negative 35 here and the 2 right there. Again, my goal is to figure out which numbers multiply to be negative 35 and add up to be 2. So maybe you tried these right away. I don't know. Negative 7 times 5. To me, those numbers make a lot of sense because they multiply to be negative 35. But they add up to be negative 2, and they're supposed to add up to be positive 2. So hopefully in these moments you can see just how close you are, and that the correct way to do this would be positive 7 times negative 5. Because those two numbers add to be negative 35, but then they add to be a positive 2 instead of a negative 2. Okay, so finally I turn to my box. And in the box I put my first term in the upper left. I put my C term in the lower right. Remember, the sign in front of the term stays with the term. And then, of course, I take my two special numbers from my x and I put them on the diagonals. So that would be 7x and negative 5x. Again, just a reminder, it does not matter which order you put those in. Just get them in there, and it'll work out fine as long as you do the factoring, the GCF factoring correctly. So here we go. Along the blue arrow, I see a common factor of 7. The finishing box is positive, so we just leave that a positive 7. Along the yellow arrow, I see a common factor of x. They both definitely have an x, and I see they both have a 5. So I'll factor out 5x. Again, the finishing box is positive, so we leave that as a positive 5x. along the red arrow. Gosh, I don't see a common factor at all. So in those cases, it's a 1. But our finishing box is negative, so I factor out a negative 1. And then last, along the orange arrow, I see that both of those terms have an x, and I think that's it. I don't think they have anything else in common. So my final factored expression would be 5x plus 7 times x minus 1. And again, these two expressions, this one up here and this one down here, they're the exact same expression. One of them's factored, the one that we just found there in that orange box, and the other one is not factored. So we want to finish with a factored form because it asked us to factor, so we know we're done. So I'm hoping that you've seen all the repetition here. We've basically done the same thing 4 times in a row. Hopefully you did a great job. Maybe if it didn't go as well, I hope this video has helped you. If the video didn't help you, I would encourage you to try it again. You need to be really, really good at these, and this is a great opportunity to do so. Of course, you can see here at the bottom it says practice factoring at the board. I would encourage you to check out your WebAssign. Your WebAssign has a number of factoring questions in it, and this is a great opportunity for you to reinforce and make sure that you have this factoring down as well as you can at this point. So again, I hope you enjoy your weekend. Don't forget your test over Unit 4 is going to be on Tuesday. So be preparing for that. Continue working through that big review assignment and old notes, old packets, old DMRs, all the stuff that you'll need to be good at for that test. Have a great weekend. See you on Tuesday.